Hello, and welcome to the AI HDL final design phase. Today, we will be covering what hardware security is, some challenges you may face when securing hardware, and how AI can help improve hardware security as a whole. Let's start by understanding what hardware security is. Hardware security refers to the protection of hardware devices from tampering, reverse engineering, and physical attacks. Why does it matter? Well, nearly every system we use in our daily lives relies on hardware, whether it's smartphones, cars, satellites, or other connected devices. Ensuring these systems are secure is crucial to prevent hacking, data breaches, and privacy invasions, which are major threats in today's connected world. Let's go over some key concepts that are important to understand when talking about hardware security. Vulnerabilities are flaws in hardware design that can be exploited. For example, some Intel CPUs had floating point precision problems that led to issues down the line. Exploits are methods to take advantage of these vulnerabilities, using things such as power analysis attacks or tampering. A notable example is cold boot attacks, which can extract sensitive data from someone's random access memory. Threats are potential dangers to hardware systems, such as unauthorized access, data theft, or physical tampering. Threat models are a structured approach to identifying, assessing, and addressing these threats by understanding the system's vulnerabilities and attack surfaces. Using threat models can help us proactively secure our hardware designs. So, why now? Securing hardware is critical today due to the increasing sophistication of physical and cyber threats. Advanced physical attacks target modern devices, including IoT and AI-based systems, making them vulnerable to manipulation and data theft. As more devices connect to the internet, the risk of cyber threats increases, necessitating stronger hardware defenses to keep these systems safe. Let's look at an example. Here, we are looking at hardware Trojans, malicious modifications to hardware designs like Verilog code that introduce hidden functionality or exploit vulnerabilities. In Verilog, these can appear in a few ways. First, conditional trigger logic, where hidden triggers activate under rare conditions, staying undetected during testing. Second, unused logic, which seems inactive but gets triggered during an attack. And third, parameter manipulations, where timing or delays are altered to degrade performance or introduce errors. So, how do we protect our system from these attacks? There are a few ways, but the most important one is to follow safe coding practices and make sure you address errors and warnings as they appear. In our case, ensuring that ChatGPT has generated safe code and scanning the code multiple times with ChatGPT will be one of our most effective options to detect any security vulnerabilities. However, there are other hardware threats besides Trojans that you must look out for. Physical tampering, counterfeit components, and side channel attacks are all very common hardware threats besides hardware Trojans. Understanding and being aware of these attacks demonstrates the importance of hardware security measures to safeguard systems against constantly evolving threats. Hardware attacks are a very real threat to all FPGA designs, including yours. Let's now implement everything we have learned into our Verilog digital watch designs to ensure that they are secure. Currently, there is no validation to confirm that the correct user is interacting with the device. Attackers could inject unauthorized commands, like stopping it during critical measurements, resetting it at an inappropriate time, or tampering with the results. To stop this, we will implement a security key that must be verified in order for the device to be used. We will prompt ChatGPT to add a secure authentication mechanism to our digital watch design. ChatGPT will return the updated code along with the specific design details for what it has generated. We will now copy this code and paste it into our digital watch design. After doing so, we will have successfully added a mechanism to prevent our watch from being accessed by unauthorized users. Another potential exploit is the lack of a default state for the outputs of our system. Not setting default states can cause massive instabilities, especially if a state is considered to be null or otherwise missing. This could lead to attacks on the system that were not seen before, creating a new vulnerability. To mitigate this, we will initialize all outputs in our system. First, we must prompt ChatGPT to initialize all of the outputs in our system. Here is all of the code that ChatGPT has returned, as well as a short description of the key changes, those being an initialization block and reset handling. Let's copy the code and paste it into our current watch design. Here, you can see the initialization block mentioned earlier, showing all of our system's outputs initialized to 0. Want to learn more? Well, we've got you covered. Check out these resources to get more information on AI and hardware design. We would like to thank all of our sponsors for supporting AI HDL.